Hi, I'm Michael Tirapta from BSCE 4B. I'm going to report about the losses due to friction in hydraulics. Losses due to friction is when the pressure is expressed in terms of the equivalent height of a column of that fluid, as is common with water. The friction loss is expressed as S, the head loss, per length of pipe, a dimensionless quantity also known as the hydraulic slope. In characterizing friction loss is which is due to the shear stress between the pipe surface and the fluid flowing within. Depends on the conditions of flow and the physical properties of the system. These conditions can be encapsulated into a dimensionless number Re, known as the Reynolds number, or Reynolds number equals to the velocity multiplied by the density divided by the viscosity, or where V is the mean of fluid velocity and D is the diameter of the cylindrical pipe. In these expressions, the properties of the fluid itself are reduced to the kinematic viscosity V, or V equals to the viscosity of the fluid over P. In quantities that enters into a determination of the Reynolds number for round type, we have here the quantity, the symbol, the SI units, and the US units, where you can read the quantity. Velocity is expressed as meter per second, or in US units, the feet per seconds. The diameter in SI units, we can write it in the D, or in US units, feet. And density, in SI units, kilogram over meter cube, or US units, slugs over the feet cube. In dynamic viscosity, SI units, kilogram over meter times seconds, and US units, slugs over feet multiplied by seconds. In kinematic viscosity, SI units is meter squared over second, and US units is feet squared over seconds. In friction loss due in straight pipes, the friction loss in uniform, straight section of pipe known as the major loss. It is caused by the effect of viscosity, the movement of the fluid molecules against each other, or against the possibly rough wall of the pipe. Here, it is greatly affected by the whether the flow is laminar or the Reynolds number if greater than 2000, or turbulent Re if less than 4000. In laminar flow, losses are proportional to fluid velocity, V. That velocity varies smoothly between the bulk of the fluid and the pipe surface, where it is zero. The roughness of the pipe surface influences neither the fluid flow nor the friction loss. In turbulent flow, losses are proportional to the square of the fluid velocity, V squared. Here, a layer of chaotic eddies and vortices near the pipe surface called viscous sublayer forms of the transition of bulk flow. In this domain, the effect of the roughness of the pipe surface must be considered. It is useful to characterize that roughness as the ratio of the roughness height to the pipe diameter D. Relative roughness. Three subdomains pertains to turbulent flow. In the smooth pipe domain, friction loss is relatively insensitive to roughness. Second, in the rough pipe domain, friction loss is dominated by the relative roughness and is insensitive to Reynolds number. In the transition domain, friction loss is sensitive to both. For Reynolds number, 2000 is greater than Reynolds number, and Reynolds number is greater than 4000. The flow is unstable, varying with times as vortices within the flow form and vanishes randomly. This domain of flow is not well modeled, nor are the details well understood. For friction, Factors other than straight pipe flow induces friction loss. These are known as minor loss. Fittings such as bends, coupling, valves, or transition in hose or pipe diameter or object intruded into the fluid flow. For the purposes of calculating the total friction loss of a system, the sources of form frictions are something reduces to an equivalent length of pipe. Energy loss in pipes due to friction. When a fluid travels in a pipe, energy is dissipated by friction. The amount of energy lost depends on a number of factors such as the fluid speed and viscosity. If the flow is turbulent, it can even depend on the roughness of the pipe walls. Losses due to frictions will cause the pressure to decrease along the length of the pipe. Therefore, increasing the amount of power that a pump must deliver to maintain the flow. These losses can become significant in systems where long stretches of piping are employed. For example, in heat exchangers, oil pipeline, fire protection system. Number one problem is if the water is having a kinematic viscosity of V equals to 13 times 10 raised to the power of 4 meter squared per second, flows in a 100 meter diameter pipe at velocity of 4.5 meter per second. Is the flow is laminar or turbulent? Well, in this problem, we're gonna identify if this problem can be called laminar or turbulent. Here's our formula. The Reynolds number is equals to the velocity multiplied by the diameter divided by the viscosity. So, here is our velocity is 4.5 multiplied by 0.1 our diameter divided by 1.3 times 10 raised to the 4. So, if we're gonna calculate that, 4.5 multiplied by 0.1 over to the 1.3 times 10 raised to the power of 4, it is equals by 3.461538462 times 10 raised to negative 5, or can be written as 346,154. It was greater than 2,000, so it was turbulent. Here's the answer. Now in our problem number 2, a fluid having a viscosity equals to 4 times 10 raised to negative 5 meter per second flows in a 750 meter long pipe having a diameter of 20 millimeter. Determine the head loss required to maintain a velocity of 3 meter per second. So we're gonna use again the Reynolds formula, or the Reynolds number equals to the viscosity multiplied by the diameter over to the velocity. So our viscosity is 3 multiplied by 0.02 our diameter over 4 times 10 raised to power of negative 5. The formula, we can calculate that. 3 times 0.02 divided by 4 times 10 raised to the power of negative 5. Equals 1,500. It was less than 2,000, so it was a laminar. We're gonna now identify the value of F, or F is equals to 64 over the Reynolds number. So 64 over 1,500. We're gonna calculate that. 64 over 1,500 is equals to 0.043, or continue lang natin, 42667. Now for the head loss, we have our formula here. The head loss equals to F multiplied by L over the diameter times V squared over 2G. So 0.04267 multiplied by our long pipe, which is 750 meter, over our diameter, which is 0.02, multiplied by our velocity, which is 3 squared, 2 times the gravity, which is 9.81. So we're gonna calculate that. 0.04267 multiplied by 750 over 0.02 multiplied by our V, which is 3 squared, then 2 times 9.81 equals 733.95 meter. That's the final answer of the head loss in problem number 2. Hi, I'm going to calculate today the fluid dynamics. So we have our Bernoulli's and flow in pipes formula, these three. And in hydraulics, calculating losses due to friction. So we're gonna calculate today the frictional head loss. In this particular instance, when our pipe has 100 meter long, that is made of cast iron, and it has 2 inches in diameter, flowing through it at water at 20 degrees Celsius will be, our volume is 2 meter per second. So we need to determine if the fluid is going to laminar or turbulent. So you're gonna calculate by using Reynolds number. The RE is equals to PV over M, or the Reynolds number is equals to 1,000 kilogram per cubic meter times to the velocity of 2 multiplied by our density at our diameter, which is 2 inches. So we're gonna convert it in meters, so it will going to be 0.0508 divided by our internal coefficient, dynamic physical coefficient of water, which is 20 degrees centigrade, which is 0.001002 internal coefficient. So that will be in millimeters. So we have 0.15 millimeters over to the 50.8 millimeters. So that will be 3 times 10 raised to the power of negative 3, or 0.003. So as we remember, we have our 100,397, so that probably 10 raised to 5, and then our relative roughness, which is 0.003. So we're gonna cross here, which is here is the 10 raised to 5, and this is 0.03. So probably we have to get in here. So we're gonna approximately it by, so that will be going to be 0.028. So our frictional factor is 0.028. So we're gonna calculate the head loss is equals to frictional factor times to the length times V squared over 2dg, which is, so we have our frictional head loss is equals to 0.028 multiplied by 100 meter length times our d, which is 2, over 2 times 0.0508 multiplied by the gravity of 9.81. So, in calculating that, we can get the 11.2 meter answer. Thank you for listening. Take care.